Welcome to another episode of the Basic Mathematics series from FNM Labs. In this session, we will discuss about the least common multiple of a set of numbers. As we did in previous episodes, we will discuss it in 3 sections. In the first section, we will see what exactly is LCM. Then we will discuss the 3 methods to find LCM, and the third section will demonstrate practical use of it. So that being said, let's dive into it. To understand LCM, it's vital to understand what are multiples and common multiples. For instance, let's consider an extract of the multiplication table of 3. Obviously, on the right side of the table, each row represents the successive multiples of 3. Let's write multiples of the 2 numbers, say 2 and 3, vertically, as shown in the table. Interestingly, 6 is present in both the lists. If we go further down the list, we can notice that 12 and 18 are also common among the 2 lists. So these are common multiples of 2 and 3, and they are the first 3 in the list. The least value among these common multiples, that is 6 here, is termed as the LCM, the least common multiple of 2 and 3. So the LCM of 2 and 3 is 6. In other words, LCM is the smallest number that is exactly divisible by each of the given numbers. Now we will discuss different methods to find LCM. In general, there are 3 commonly used methods to find LCM. They are common multiple method, prime factor method, and common division method. Let us discuss common multiple method in detail. To explain the method, let's try to find LCM of the numbers 2, 3, and 4. For this, we list first a few multiples of the numbers. And then from the list, we select common ones. We see the numbers 12, 24, 36, 48, 60 are common multiples. The list continues further beyond 60 also. The lowest of the numbers is obviously 12. So the LCM of 2, 3, and 4 is 12. As we found LCM from common multiples of the numbers, this method is named as common multiple method. Meanwhile, it's worth noting that all the common multiples are multiples of the LCM. Next, we will discuss another method, which is called prime factor method. As the name indicates, this method utilizes the prime factorization process. We will work together to find LCM of 18, 24, and 36 using prime factorization method. To begin with, we need to express the numbers as product of its prime factors and then in index form. But before that, let's see how to express the number 18 as the product of powers of prime factors. We divide 18 by the least prime factor 2. We get quotient 9. Next we divide by 3 to get 3 as quotient. So 18 can be expressed as a product of prime numbers 2 and 3, and finally as the exponential expression as 2 raised to power 1 into 3 raised to 2. In the same manner, we can express 24 and 36 as product of powers of its primes. Coming back to our prime factor method, now we have expressed 18, 24, and 36 as powers of its prime factors. Then we mark each prime factor with its highest power. Now the LCM will be product of these highest indexed values of prime factors. And finally, we will discuss the third method to find LCM, the common division method. Take the numbers 16, 20, and 24. Let us try to find LCM using common division method. For this, we write the numbers side by side in a line separated by commas. Then we find a suitable number that exactly divides at least two of the given numbers. In this case, as the numbers are even, the number 2 divides all the three. Write down the quotients below the line. In any case, if the number is not divisible by the divisor but remains undivided, we write it as it is below the line. We need to repeat the division process until we get quotients which are prime to each other. Now we multiply all the divisors on the left side and the numbers in the last row to get LCM. Next, we will familiarize a couple of notable features connecting LCM and HCF. First one is a specific relationship between the least common multiple of two numbers and their highest common factor. If you take two numbers, the product of the numbers will be equal to the product of their LCM and HCF. That means if A and B are two numbers, then A into B equals HCF into LCM. Let us consider an example. A is 80 and B is 50. Now their product is 4000. You can see HCF of 80 and 50 will be 10 and their LCM is 400. Obviously, HCF into LCM is again 4000. Referring to the table given here, you can get some more examples showing this behavior. Meanwhile, this is applicable only with two numbers. Another feature connecting LCM and HCF is that LCM of a given set of numbers always contains HCF as one of its factors. For example, consider the numbers 10, 15 and 20. HCF of these numbers is 5 and LCM is 60. Obviously, 60 is a multiple of 5, which implies that HCF is a factor of LCM. In a similar manner, considering another example, 24, 28 and 48, their HCF is 4 and LCM is 336. And you can see 336 is a multiple of 4, which implies that HCF again is a factor of LCM. Or in brief, we can write LCM as a product of some integer and their HCF. It's always good and interesting to sit back a while and think about what exactly the mathematical concepts mean. How can we relate to something that we see or experience in our life in a similar note to enhance our understanding of LCM? Let's think of a situation consisting of three objects, blue, green and red, revolving along three different orbits around a fixed object. For the ease of demonstration, let's assume the closer blue object takes 2 hours to complete one revolution. Likewise, the middle green takes 3 hours and the farther red one takes 4 hours. Even though it starts together on a line, we can see that they do not meet together on the line at successive revolution. Now the question is, will they meet again? If yes, when will they meet? Let's draw a flag line and add a timer showing hours. You can also see the time each of the objects passes the flag line. After the start from the flag line at 0 hours, you see they pass together the flag line at the 12th hour and then at 24th hour and again at 36th hour and so on. You remember we had earlier calculated the LCM of 2, 3 and 4 as 12th. This shows the objects meet on the flag line on the hours, which is either LCM of the periods of revolution of the objects or at the hours, which are multiples of the LCM. Hope you enjoyed the video. Open your eyes and minds towards the mathematical concepts you encounter and always try to identify their counterparts in the nature around you. You can see a wonderful mathematical world opening before you. That's all for now. Meet you in the next video with a different topic.